In this video, we are going to learn about change of base or change of base formula for logarithmic function. So let a and b and x be positive real numbers such that a is not equal to 1 and b is not equal to 1. Then log x base a can be converted to different base as follows. So we have the base b, we have log x base a is equals to log x b all over by log a base b. If it is base 10, we have log x base a is equals to log x over log we have a. If it is base e, which is the natural logarithm, so you will have now as log x base a is equals to ln x all over by we have ln a. So these are the important formulas when you are going to solve problems related to logarithm with different base. So how did we come up with, how did we derive logarithm of x base a equal to log x over b log a over b? So let's try to derive the equation. So log x base b is equal to, we have log x base b is equals to y, which is base exponent. So we have here, when you can observe, if we are going to derive, or if you're going to convert logarithmic function into, we have exponential function, you're going to have now as base, exponent, and the value of x. Therefore, we have logarithm of x base b is equals to y, which is equal also to b to the power of y equals to x, which is, we cannot solve problem with different base. So therefore, we are going to put logarithm on both sides, which is log by is equals to log x. And then here, okay, so from here, which is in the properties of logarithm, if you have this one, okay, which is in the power property, we give us, okay, so we will have now log m to the power of n, which gives us, we have n logarithmic of m. Therefore, we have now as y log b is equals to log we have x. And then we have both sides have different logarithm. So therefore, we will divide both sides by logarithm of b. That's the reason why we have this formula, which is y is equals to log x all over by log b, or we can have now log x base b is equals to logarithm of x all over by logarithm of b. Okay, let's try to solve some examples. Okay, for example, we have 5 to the power of 2x plus 1 equal to 6x minus 2. Okay, so we are going to find what is the value of x. Here we don't have the same base, which is 5 and 6. So therefore, we will solve this problem in accordance with, we have logarithmic function with change of base. So therefore, what you're going to do is you are going to put logarithm 5 to the power of 2x plus 1 equals to logarithm of 6x minus 2. And then property number 3, we have now as logarithm of m to the power of n is equal to n. Okay, so we have n logarithm of m. So therefore, you will have now as 2x plus 1 times logarithm of 5 equals to x minus 2 log we have 6. Next, we are going to distribute all the values of the logarithm. So therefore, you will have 2x log 5 plus log we have 5 equal to multiply x times logarithm of 6. So you have logarithm of our x logarithm of 6 minus 2 log 6. So from here, you can observe that we have common factors, which is x and x, or common variable. So therefore, you're going to move the value of x log x into the left side. So you will have now as 2x. 2x, we have log 5 minus x log 6. And then this one, you move on the other side as well, which gives us equals to negative log 5 minus 2 log 6. After that, factor out common factor, which is the common factor here is x. Therefore, we will have x times 2 log 5 minus, we have log 6, equals to, we factor out negative, therefore you will have log 5, okay, plus 2 log 6. Now, here we have 2 log 5, going back to this property, okay, going back to this property. So therefore you will get now as x equals to, x, okay, just make it step by step, x log 5 squared minus log, we have 6, equals to negative log, we have 5, plus we get now as log 6 squared. Okay, and then after that, divide both sides by logarithm of 5 squared minus log, we have 6. So therefore you will get now as equal to, so from here you move on this side, we have now as x, okay, x equal to, okay, so we'll just make that one as arrow, x is equals to negative log, we have 5 plus log 6 squared, which is equals to 36. We'll just go for that one, 36, all over by log 5 squared, which is 25, minus log, we have 6. How we will get the exact value? So when you're going to plug in your calculator, you can get log 5 plus 6 in the loss of logarithm, which is log m plus log n equals to log m n. So therefore, you will get now as minus log, we have 5 times, okay, times 36, all over by, this one is for product. How about for minus or for division? So this one is also a property of logarithm. Therefore, this one will become log m minus log n, okay, log m equal to log m over log n. So therefore, you will get now as log 25 over 6. And then after that, plug in your calculator, you can get the answer equal to approximately, okay, around negative 3.64. Okay, so this is how you will find the value of the logarithm, which is finding the exponential function here. Okay, so this is the value of x. Next question. Next problem is about logarithm with different base. So what you're going to remember, this one, log x base a is equals to logarithm of x all over by log, we have a, okay? So from here, we have 4 and 2. So therefore, what you're going to do, you're going to find the common factor of 4 and 2, which is equals to 2, or the lowest common factor of 4 and 2 is equals to 2. So therefore, we will try to make this one as base 2. So you have now log x base 2 all over by log 4 base 2 plus log x base 2 is equals to 6. If you're going to make this one, to convert this one, we have now log 4 base 2 is equals to x. So 2 to the power of x equals to 4, which gives us x is equals to 2. Okay? So we get now as log x base 2 all over 2 plus log, we have x base 2 equals to 6. From here, we can get now as 1 over 2 log x base 2 plus log x base 2 equals to 6. This one is also the same as if you're going to multiply x, okay? X times 1 over 2, that is equals to x over, we have 2, or also it can be 1 over 2x. That is the reason why we have log x base 2 over 2 is equals to 1/2 log x base 2. That's the reason why we get that one, so that we can come up with this logarithm, or m log n, to become log, we have n raised to the power of m, or you can have different ways. So therefore you will have now as here, can have as n, m, and then we get m to the power of n. So next step, we will have log x base 2 raised to the power of 1 over 2 plus log, we have x base 2 equals to 6. And then this one, we convert everything into exponential function. So we will get now as x 1/2 times, we have x equals to 6. Here, okay, so this one, a lot of students get mistakes, or a lot of us get mistakes because we neglect the base. So you will get now as 2 to the power of 6. So multiply this one, am times an will give us am plus n. Therefore, we will have x 1/2 plus 1 will get 3 over 2 equals to 2 to the power of 6, which is 2 to the power of 6, which is 2 times 2 times 2. We will get that one as 64. To eliminate the fraction, we will multiply both sides by 2 over 3, 2 over 3. So we get now x equals to this one in the rule of cubes or radicals. So we'll get as cube root of 64. We have cube root of 64 squared. If you're going to simplify this one more further, cube root of 64 is equals to, we have 4 and then 4 squared. So therefore, the value of x is equals to 16. So when you're going to check if your answer is correct, just plug in, we have the value of 16 here. Is it equal to 6? So try to solve with that one. So therefore, you will have now as log 16 base 4 plus log, we have 16 base 2. So 2 to the power of, okay, 2, we have 4 squared. This one is 2. Okay, so we'll just change that one into 2. Plus, we have this one is 4 equals to 6. So therefore, we get 4 plus 2 is equals to 6. Okay, so if you have questions and clarifications, if you have to ask help about mathematical problem, mathematics, please send comment, or we have comment below in the comment section, or always click the notification bell and subscribe this channel so that you will be updated whatever we have lessons or we have problems in mathematics we're going to do. Thank you so much and have a nice day to everyone. God bless.